You ever wonder what's really going on when you click a link or type in a web address? I mean, it feels instant, right? Almost like magic. One moment you've got a blank screen, and the next, poof, a whole website appears. Well, today we're going to pull back the curtain on that magic trick. So let's start right there. You type in an address, you hit enter, and you've just kicked off an incredible, high-speed journey that zips across the entire globe. We're going to follow that single click and see exactly where it goes. So first things first, we got to get one thing straight. The internet isn't some fluffy, abstract cloud up in the sky. Nope. It's a very real, very physical thing. It's this massive, interconnected web of actual cables, routers, and servers that stretches across the whole planet. And here's the secret. The internet isn't just one giant network. It's actually a network of networks. It connects the small local area network, that's your LAN, like your home Wi-Fi, to much larger wide area networks, or WANs. By linking all of these together, your computer can talk to a server on the other side of the world like it's sitting right next to it. Okay, but before our request can even start its journey, it needs to know where it's going. You know, it's just like sending a letter. You can't just write a person's name on the envelope. You need a specific street address. The internet works the exact same way. What we type into our browser, that's called a domain name. You can think of it as the name of a store. It's super easy for us humans to remember. But the internet's postal service, well, it needs a lot more than just the store's name. It needs the real address. See, computers don't do names, they do numbers. And that specific number is called an IP address. This is the real deal, the precise street address and zip code for every single device connected to the internet. Everyone is totally unique, which makes sure your data gets to the exact right place. So this is the puzzle, right? On the left, you've got the simple name we can all remember. On the right, you have the series of numbers that the network actually needs. So how in the world does your browser connect the two? It all happens with something called a DNS lookup. DNS stands for Domain Name System, but you can just think of it as the internet's giant shared address book. Your computer basically asks a DNS server, hey, what's the number for this website? The server looks it up, finds the matching IP address, and sends it right back. And all of this, it happens in a fraction of a second. All right, so we've got the address. Now we have to get our message ready for its big trip. And you might be surprised to hear that we don't just send our request as one big file. No way. Instead, we chop it up into tiny little pieces. These little pieces are called packets. Just imagine trying to mail a massive encyclopedia. It'd be way safer and more efficient to send it one page at a time, right? With each page clearly labeled with the destination address. That's exactly what a packet is. A tiny piece of the big message with its own address information stamped right on it. And this method, which is called packet switching, is unbelievably efficient. The old way of doing things, circuit switching, was kind of like booking a private road just for your message to travel on. Nothing else could use it. Packet switching is more like a public mail system. The packets can take all different routes to avoid traffic jams, and millions of different messages can share the same roads all at once. It's what makes the internet so incredibly powerful. So you might be wondering, how does this organized chaos actually stay organized? Well, it's all thanks to a set of rules called a communication protocol. The main one you'll hear about is TCP/IP. Think of it like this. The IP part is the one that writes the correct address on each of those little packets. And the TCP part, that's the one that numbers each packet, does a roll call to make sure they all arrive safely, and then puts them all back in the right order at the other end. This whole process is organized into these neat layers. Your request starts way up at the top, in the application layer. That's where your browser is. As it moves down the stack, each layer adds another piece of information. The transport layer handles the error checking, the internet layer adds that crucial IP address. It's like a digital assembly line, perfectly preparing your data for its physical journey. Okay, our packets are addressed, they're wrapped up, and they are ready to go. Now they have to navigate the world's biggest, busiest network, the physical internet itself, to find the server they're looking for. And the MVPs of this journey are the routers. A router is basically a postal sorting office for data. It looks at the IP address on every single packet that comes through and in a split second decides the most efficient path to send it on next. Your request will literally hop through dozens of these routers, crossing continents and oceans in just milliseconds. Now, when you're browsing the web like we are in this example, you're usually using what's called a client-server system. It's simple. Your computer is the client, and it's requesting information. The website's computer is the server, and it provides that information. This is a bit different from a peer-to-peer system where computers just share files directly with each other. And that server our packets are flying towards, it could be doing all sorts of jobs. But for ArcClick, it's a web server. Its one and only purpose is to find the web page we asked for and then send it all the way back to us by, you guessed it, breaking it into its own packets and starting the return journey. So we've covered the what and the how, but maybe the most mind-blowing part of this whole thing is the speed. I mean, this entire super complex process, the address lookup, chopping up the data, the journey across the world and back again, it all happens in the blink of an eye. You've probably seen speeds like this advertised, right? 1 gigabit per second. It sounds fast, but what does that actually mean when you're just trying to load a web page? Well, it all comes down to this. Transfer speed is measured in bits per second. A bit is the absolute smallest unit of digital data you can have. So a bigger BPS number just means more of those data packets can fly down the line every single second. Let's make this totally real. Say you're downloading a 20 megabyte photo and your connection is 40 megabits per second. First, we have to convert the file size into bits. That's a whopping 160 million. Then we just divide that by our speed, which is 40 million bits every second. And the result? 4 seconds. That is it. Just 4 seconds to move 160 million tiny pieces of information across the planet to your screen. It's incredible. So there you have it. From your single click to a fully loaded web page, it's this intricate dance of protocols, packets, and routers, all happening across a real, physical, global network. It's a system of almost unimaginable complexity that we managed to build in just a few decades. And that really makes you wonder, what comes next? What are we going to build with this incredible tool tomorrow?